Visible from space, as this satellite image shows, phytoplankton form enormous green swirls hundreds of miles long around coastal waters, which are rich in the nutrients these plants need to live on. They use photosynthesis to absorb sunlight, as well as carbon dioxide from seawater.
Just like trees, they take the carbon dioxide and give us back oxygen. These phytoplankton, these amazing little plants, may be holding the key to saving the planet.
Ian Jones believes that by adding nutrients to areas of the ocean that lack phytoplankton, he can turn them into a lush forest that will reverse the effects of global warming by absorbing carbon dioxide. In 1995, a team of American oceanographers set out to study the desolate zone. That's an area 250 miles to the southwest of the Galapagos Islands, where there is little phytoplankton. They wanted to find out what was making the desolate zone so desolate. The theory? That it was missing a vital nutrient, iron. So half a ton of iron was added to the sea. Ken Cole was one of the scientists on board and witnessed what happened next.
Results from the Iron X2 near the Galapagos were dramatic and turned the ocean green for miles. There were scientists that would walk out and look at this green ocean and burst into tears at the dramatic way in which a small amount of iron would have such a huge effect on a community. And this was sort of like discovering, the key to climate change.
When CO2 is absorbed by phytoplankton, it releases oxygen, with the remaining carbon staying in the plankton. When the plankton die, they sink to the deep ocean floor, taking the carbon with them. By the end of the expedition, the scientists had calculated that this small area of phytoplankton had absorbed an additional 7,000 tons of CO2, the equivalent to over 2,000 fully grown redwood trees. But back in Australia, Ian Jones is convinced that his plan to use nitrogen-rich urea will have a wider use than iron. Only 20% of the oceans, like the desolate zone, need iron to grow more phytoplankton. Nitrogen would act as a more general booster in a whopping 80% of the oceans, so Jones thinks that his idea would be more effective. But Ian Jones's idea of making the oceans bloom by boosting them with nitrogen may have a very serious downside. Fish have died where there is an excess of phytoplankton, but Ian Jones thinks he can control the phytoplankton at levels that won't kill marine life. So his plan will only work where there is not much phytoplankton to begin with.
But the important about ocean nourishment is we're not doing it where there's lots of productivity, we're doing it in the desert regions of the ocean.
If you don't like the outcome of ocean nourishment, of course, you can just turn off the tap. This is like irrigating the desert. If you irrigate the desert, the plants bloom, but if you turn off the water, they just die and go away. The same thing will happen in the ocean. When you turn off the food supply for the plankton, they'll just die and fall to the deep ocean.
The benefit of urea as a successful fertilizer is evident on most agricultural land. It is rich in nitrogen, used by farmers to fertilize their crops. So Ian Jones has turned to an agricultural solution to produce his nitrogen in a form that can be added to the ocean: urea granules. He's met up with environmental scientist John Ridley at this fertilizer factory.
Nitrogen's a very common element in the atmosphere. About 80% of the atmosphere is nitrogen and about 20% is oxygen. So nitrogen is readily available. It's just not in the form that we can use for nourishing the oceans.
The nitrogen, fixed in urea granules, should be easy to transfer and dissolve in seawater. But should we be meddling with an ecosystem that's taken millions of years to evolve?
We've changed the planet, and once you start managing nature, you have to continue to manage nature. There's no use hoping that it'll restore itself to a new equilibrium set up by humans. Nature will need to be managed forever now that we've changed it dramatically.
A fifth plan was on the table of the scientists in the California conference: to take carbon dioxide out of the air. Not this time by altering the ocean, but by mimicking the action of one of the greatest carbon capturers on Earth: trees. Geophysicist Klaus Lackner is working on an idea that many believe is the frontrunner in cutting greenhouse gases. He wants to take carbon dioxide out of the atmosphere and store it deep underground.
In order to stop climate change, we need to collect the carbon dioxide back from the atmosphere. We believe we can do that, and once the carbon dioxide is collected, it can be put away safely and permanently for thousands and thousands of years.
People will need heat. In the summer they will need air conditioning. Energy is just critical, and it's very difficult to take the largest energy source out of the system and at the same time provide much more energy for more people who want to get to a decent standard of living.
Klaus Lackner has designed an amazing machine, a synthetic tree, which will remove CO2 directly from the air all around us, giving the world some breathing space whilst alternative, carbon-neutral energy sources could be developed. It was Klaus Lackner's teenage daughter Claire that gave him the inspiration to solve this problem when she was looking for a school science project.
Then I said, why don't we pull carbon dioxide out of the atmosphere? And so she actually showed that this can be done. She took air, blew it through a solution of sodium hydroxide, and she showed that overnight she collected half of the CO2 from the air which she bubbled through her sodium hydroxide solution. These walls here are perforated, so it's easy for air to move through. There's a similar wall on the inside, opening a tube where the air goes through. There's a fan right here which will suck the air through the system and blow it out towards the top. As the air goes through, it goes through this layer in between here, which is filled with this packing material you see here. This is material that is very open. If you blow air through, it easily goes through. They are wetted with a sodium hydroxide solution.
Sodium hydroxide is the key to the success of this idea. When CO2 comes into contact with sodium hydroxide, it is absorbed, producing a liquid solution of sodium carbonate.
The liquid percolates down, is eventually collected in this bucket at the bottom. As the air comes out, it has less CO2 in it, substantially less CO2 than when it came in.
The liquid containing the CO2 is then piped away to be processed, turned into a concentrated gas in preparation for its final storage. Klaus Lackner's vision is to have thousands of artificial trees, like wind farms, filtering out the world's carbon dioxide. He estimates that a single one of these artificial trees would remove 90,000 tons of carbon dioxide a year, the equivalent emissions of over 20,000 cars.
One possibility for storing vast amounts of carbon dioxide is below the seabed, where the ocean is very deep. The seabed floor is a rock not unlike these, and it's quite porous. You can actually get carbon dioxide squished into the pores of this material, and it will stay there because it's denser than water.
Using existing oil drilling technology, channels thousands of meters deep would be drilled into the seabed, and the carbon dioxide gas would be injected into it, permeating the surrounding porous rock. At this depth and low temperature, the carbon dioxide is denser than water, locking it in place.
And it cannot rise from there to the ocean floor, so it's put away literally for millions of years.
It's going to take a great sea change in lifestyles to reduce carbon dioxide emissions to a manageable level. So Klaus Lackner believes his synthetic trees would buy us the time we need by regulating carbon dioxide levels.
I am very optimistic that a solution to global warming can be found. I believe that synthetic trees will play a role in that, and that they will play a role in how the energy landscape of the future will look.